Good morning and welcome everyone to the first and the largest online Python conference in Sri Lanka, organized by Isaac University of Moratuwa in collaboration with Matific Sri Lanka. PyCon Sri Lanka 2022. I'm Sadhani Ayesha, the moderator for the conference today. We are privileged to bring together the Sri Lankan Python community with a diverse set of speakers from around the world. PyCon Sri Lanka is bringing together speakers across the world to share knowledge on 3 tracks: General, Python for Web, and Python for Data. From beginners to professionals, the tracks are open to all of you. You can join a track according to your preference. So, before moving on to the sessions, I would like to welcome the CEO of Matific, the diamond partner behind PyCon Sri Lanka, Mr. Craig Shotland, to deliver the welcome address. The stage is yours, Mr. Craig.
Thank you very much, Sanduni. Hello, everyone, and welcome to PyCon Sri Lanka 2022. My name is Craig Shotland, and I'm the CEO of Matific. For those of you who are not aware, Matific is an educational platform that teaches primary school students mathematics. Our vision is to provide every student around the world with the highest quality maths education possible. Based in Australia, we are a truly global company and have offices in over 20 countries around the world. Around 18 months ago, we decided to establish a development center, our third, in Colombo, Sri Lanka. Our team now consists of around 50 extremely talented IT professionals, and we have big plans to significantly expand our existing presence. Sri Lanka holds a very special place in my heart, having established and run development centers in the country previously, and visited the country more times than I can count on my hands. Like many other emerging high-tech companies around the world, we love Python. The challenge, though, is there are simply not enough highly skilled Python software developers to be found. I have found this of particular noticeability in Sri Lanka. That is why we are here, together as a highly engaged, passionate, and intelligent group of people. We can start creating, expanding, and nurturing a Python community that can meet the demands of industry. We are exceptionally proud and honored to sponsor and help organize the first PyCon in Sri Lanka. Over the course of today, we hope the speakers will inspire, educate, and challenge you. We hope you will take the passion into the broader Sri Lankan software development community to help raise the awareness of Python and the opportunities that it presents. And one final note, and please forgive me for saying this, Matific is actively hiring Python developers at all levels. Please come and chat with us at our virtual booth to learn more about having a career at Matific. I look forward to this event being an incredible success. I'm also confident that it will be the first of many in Sri Lanka. Thank you very much, and I look forward to hearing from David shortly.
Thank you, sir, for the warm welcome, and it was a privilege to know about Matific, and we are really glad that you partnered up with us for the first ever conference in Python for Sri Lanka. So without further ado, let us start PyCon Sri Lanka 2022, the biggest Python conference for Python enthusiasts. First up, we have the keynote speech, The Problem Within the Problem, by Mr. David Beazley. Mr. David Beazley is an independent author, educator, and researcher primarily known for his ongoing work in the Python community. And also, he has a PhD in computer science and an MS in mathematics. I'm glad to welcome you on stage, sir. Over to you.
Okay. Thank you very much for inviting me. You're looking at my fine basement here in Chicago, Evanston, Illinois. It's about 9:30 at night. Okay, so the problem with the problem, kind of a strange title for a talk. So as a little background, I spend much of my time teaching programming classes. They tend to be kind of more advanced, sort of classes for professional software engineers and developers and so forth. And one of the things that we do in these classes, we talk about problem solving. I mean, if you think about what we do in programming, a lot of what we're doing is trying to solve problems, practical problems for customers and things like that. So in one of my courses for the past couple of years, I've opened the course up with just a problem. It's like, hey, let's solve a problem. I'm going to show you the problem. Actually, we're actually going to work on the problem in the conference here. So, so here's the problem that I kind of open up with. Hopefully, you're seeing this on the screen share. Okay, so I'll give you a moment to kind of look over the problem. I'll kind of discuss it a little bit, but the gist of it is we have a owner of a movie theater. I kind of miss going to movies, so I have the movie theater problem here. So we have the owner of a movie theater is basically interested in finding out how to maximize his profit. If you read through it, he wants to figure out how to set ticket prices to maximize profit. Okay, so this is the problem that I open up class with. I wouldn't claim it's a very advanced problem. If you look at it, it doesn't involve anything like the web, it doesn't involve the cloud, it doesn't involve big data sets or anything real super complicated, just some numbers, little math problem, and the kind of thing that somebody might want to know the answer to, how to maximize profit. And so what I do in the class is I basically hand this problem to a bunch of professional software engineers, and I say, hey, go solve this problem. I give them no instructions at all. Okay, no information. And then we come back and talk about it. Now, little do they know that I'm actually performing a kind of science experiment, sort of a hidden agenda science experiment. Okay, so this problem actually comes from a book. Let me show you the book. So this is a problem from this book with the ambitious title, How to Design Programs, an Introduction to Programming and Computing. So this is a book that is typically taught to first-year college students as a first course in programming. It assumes no prior programming experience whatsoever. It's often taught to maybe humanities majors, liberal arts majors, in addition to people who go on to computer science. So it's very much an introductory book, and the problem that I've chosen is taken straight from that book, page 60, the movie theater problem. Okay, so one of the things I'm kind of interested in with this science experiment and giving out this problem is sort of seeing what professional developers do with a problem that's intended for beginners. In the How to Design Programs book, what they're talking a lot about is how to break problems down, computational thinking. Actually, with the the kind of the opening remarks, teaching math and things like that. That's what this book is about. It's about thinking through problems. By the way, this is not at all a Python book. There's no Python in here. They teach this in Scheme. Admittedly, that's not the most popular choice at a lot of schools. So it's a very different book. But I thought I would just sort of give this to the professionals, see what they do with it. Now, my intention in doing this was honestly just to kind of get people thinking about the things that we do in programming. There's a lot of stuff we do in programming as far as trying to break problems down into parts. Thinking about, can we make the code readable? Can we make it maintainable? Can we make it testable? There's all these things that we think about in solving a problem. Abstraction, that sort of stuff. So my intention was just to use this as kind of a jumping off point for talking about things we do in programming. As it turns out, this one problem has generated far more discussion and things in the course than I ever would have imagined. And in some sense, that's what this talk is about. I'm going to actually kind of take you through some things with this problem, things that come up when people try to solve it. This is going to be kind of a mix of things that people encounter and run into trouble with and so forth. So I think it'll be fun. In the interest of making it kind of interactive, I would encourage you to follow along. if you can. I mean, if you want to. I mean, the code for actually there is no code other than this comment. But if you want the problem, you can go to this GitHub page, and I will be monitoring the chat to the extent that I can during the conference. So if you just have some idea that you want to just throw into the chat, if I see it, I might go with it. Okay, so we might roll with it. Okay, so this is the problem, and to kind of start something like this off, one of the things that I'm really fascinated in as an educator and other things is just where do you start? Got a problem? What's the first line of code that you write? Yeah. Somebody out in the chat's like differential equations. Well, maybe. I hope not. I wasn't intending to do differential equations, but okay. No, there's this. You look at the problem. It's like, okay, where do I start the problem? There's a couple things about the problem is that it's got multiple pieces to it, right? There's a little discussion about attendance and cost and some other things, but like what's the first line of code? And so one of the things that people do, okay, I'm just going to throw this out there as one angle on this, is maybe you should start by writing a test. Test-driven development. Okay, we hear about that. Agile, test-driven development. You should write a test. And it turns out in the problem statement, there's actually some stuff you could test. I mean, if you wanted to write a test, you could do that. Maybe we'll just kind of make some stuff up here. We're going to compute attendees based off the price, and like $5.10. Okay, so we're going to pass in $5.10, and then the thing basically says that we're going to get 105. It's like, okay, we'll do some test-driven development. I mean, why not? It's something to work with, and we'll start with that. Now, what I'm going to have to do, obviously, is fill in some details about this. This function. It's like, okay, compute attendees, and I have to think about, okay, the price, like what's going to go in there? Maybe, I don't know, maybe that's going to be a float, and then maybe it will return an int of some kind. I'm just kind of sketching out some ideas about the functionality with that. Maybe I'll just start with that, and then just run it, and okay, maybe make sure the test fails. Actually, to be really proper with test-driven development, you always want to make sure it fails first, right? So you start with maybe start with a test, and then unfortunately, I'm gonna have to spring some math on you. Okay, so we got to think about some math on the problem. There's some information about, at $5, 120 people attend, and then the number of people go up or down depending on whether the price changes. And I have to kind of think through that a little bit. Okay, so I don't know, it's suddenly an economics problem instead of Fibonacci numbers or something. Okay, so to sort of think through that, I mean, you might do something like okay, we have 120 people, and then okay, maybe we'll take like the price and how far off from $5 it is. Okay, so like if it's above $5, the attendance is going to go down, and I don't know. You kind of have to kind of mess around with the math on it. It's like, okay, so if price goes up, the number of people go down. Supply and demand, and then okay, so the price is going to go down, and then I see this thing, for every 10 cents, the number of people changes by 15. And so you have to do a little kind of, like mental math on it. I think if you multiply by 150 or something, you get that. One of the benefits of tests is that if my math is wrong, the test is supposed to find it, right? So I'm relying on that. So you put in some tests, and you have a function like that. Right away, the thing is gonna crash. Got something wrong. not really sure what's wrong. So I'm going to run the maybe the Python, REPL to kind of play around with it. Okay, so we'll come in here and figure out what's happening. I actually really like this feature of Python, by the way, the fact that you can interact with the code and kind of play around with it. Love that feature. It's actually probably the thing that sold me on Python 25 years ago. So you can come in there and play around, and then it's okay. So I already see a big part of the problem with the problem here is that I'm using floating point numbers, and I'm doing a calculation with floating point numbers. And if you know anything about floating point numbers, you know that the results aren't always real accurate, right? Okay, so I've already kind of run into a problem here, and I might start thinking about the problem a little bit, like, is my assumption of this returning an integer correct or not? I don't know. Is it supposed to return a float? I mean, I don't know. Does it return an int? I don't know. What do you think? I mean, like, should compute a number of attendees return integers or not? Because you start thinking about, okay, does the movie theater care about half people, or like just the bottom part of a person show up, or I mean, it seems to make sense that you would have maybe integer people, and so I got to figure out what I want to do here. Maybe I decide to convert the thing to an int. This isn't described in the problem at all. I mean, it doesn't say anything about conversions, but I'm thinking about the types of this thing, and maybe I run it, and then it's still failing one of the tests if I do that. So you're doing it, compute attendees, and you realize that the int conversion actually truncated the result sort of down to 134, and I don't know, maybe the thing needs to be rounded instead. Okay, so we'll use the round function, and so right away I'm like already kind of off on this like tangent, dealing with ints and rounding and floats and this other stuff. Okay, so you might start the problem like that, and then shortly after doing this, somebody might say, Dave, why are you using floats? You should never use floats. You should use decimals. I mean, you should never use floats for money calculations. Like, what are you doing here? So an alternative thing might be to use something like the decimal module. They would say you should actually use decimals in here instead of floats, because floats are evil and like shouldn't use that. Okay, so maybe you should change the thing over to we're going to take a decimal in, and then if you're going to use decimals, then you have to express them correctly. One thing, well, you have to use them everywhere. So everywhere that you had a float, you're going to have to do a decimal. Okay, so you have to introduce a decimal in there. Let's do decimal 49. Okay, so you put you're going to change it over to decimals. I'm still not entirely sure about this rounding thing. Okay, I guess I'll leave it for now in the int. So I'm not totally sure about. Actually, do I want to leave that? I don't know. Let's make this a decimal too. That whole rounding thing is weird, because it's like that wasn't really specified in the problem. Doesn't say anything about rounding people, so I don't know. Let's take that out. Okay, so you change it over to decimals. You try running the code again, and now it's like failing the test again, failing the test, and I'm wondering, like, okay, why is it failing the test? Okay, so I run the function, and now I get this like even crazier answer than I had before. 135. Okay, what is going on there? Now, what is going on there is I forgot to put the quotes. This is really subtle, right? It's like when you do decimals, you got to put quotes on it. If you don't put quotes on it, it actually turns it into a float, which is already inaccurate. and then it takes that inaccurate thing and turns it into something else that's inaccurate. Okay, so I forgot to put the quotes on there. Okay, gotta go fix the code to put the put the quotes on there, and after putting the quotes on there, it now passes the test. But seeing on the quotes on there just really annoys people. Okay, so invariably somebody looks at this and they're saying, okay, Dave, I hate the quotes. It looks terrible with the quotes. And so you can kind of hack that. Okay, so one thing that I saw somebody do in a class is they wrote a function called money. And then what they did is they just returned decimal, where they converted the X into a string. It's like, oh, so this is already feeling like really kind of dubious, right? It's like, okay, what is coming in here? Is this like a float coming in and then turning it into a decimal or something? What they're thinking here is that if you turn like 4.9 into a string, it just becomes this nice string, right? So you write a function called money, and then everywhere that you want that, you just say money, right? Okay, so 5.0, and it basically solves the quoting problem. Although the whole thing kind of feels a little bit sketchy to me, to be honest. I don't know how you feel about that, but it's like, yeah, okay, it's like that just. It's just weird, very strange. Okay, so you look at that and it's, oh, okay, yeah, so we can use decimal and so forth. But having gone through all of that, somebody might might look at that and say, okay, look, I did like a bunch of embedded system stuff, 10 years ago. You don't need decimal. Just use cents or something, like convert it to ints. I mean, so another option is use ints, use cents. I mean, $1 is equal to 100 cents, right? So this other idea problem is just, okay, just forget the decimal thing. Okay, like get rid of the decimal, change the whole thing over to cents. We're going to put ints in here. Okay, we don't really, forget floats, forget cents. We'll do ints here. I mean, if you're going to do ints, though, you're going to have to multiply all the numbers by 100. Okay, so it's, instead of 5, it's 500, and maybe instead of 150, maybe it's 15,000 or something, and then 510. Okay, so you've got to change the whole thing, the whole thing over to cents, and then you're gonna run the code, hopefully with the test passing. And of course, the tests are failing, as they usually do in such situations. And so I'm going to try out, like, okay, what's going on with that? And suddenly it's saying that I have negative 150,000 attendees instead of 105 or whatever that, 135 or whatever that is. So what is this? So I'm going to scratch my head wondering what's going on with that. Basically what's happened is I've completely confused myself by introducing this cents thing, and I've forgotten the fact that this 150 actually has units on it, which is like number of attendees per dollar. The dollar is in the denominator. It's on the bottom, right? So in terms of that 150 that I had before, it actually needs to be 1.5, which takes me back to floats. I didn't want to be in floats, but now I'm back in floats. And okay, so maybe I can fix the thing by saying, well, I'll do 3 times the price, and then I'll divide the thing by 2, right? And then maybe I'll pray that the thing is an int, or maybe I'll I don't know, I'll do like truncating division or some other thing to like force this thing to be an int. And I'm just basically really confusing myself on this whole thing. I mean, I'm not even, okay, that passes the test, but I'm getting to a lot of confusion on it. here's where a lot of the confusion is coming from on this. I think there's a confusion where there's sort of units in the problem domain versus data representation in Python. I'm getting tripped up because I'm thinking about Python. I'm thinking about things like, okay, this needs to be an int in Python, or this needs to be a float, or this needs to be decimal. I'm thinking about types and all this stuff, and I'm losing sight of the problem. Like what are we trying to do here exactly? I'm trying to figure out, express a relationship between price and attendance, and I'm getting totally turned upside down, dealing with data representation and tests and all this stuff. In fact, I can't even remember what the original problem was. Like, what are we trying to do? All right, let me just pause for a second. Okay, okay, yeah, just checking out. Again, if you have some ideas, throw it in the chat. I am watching on that. So this is one thing that happens in this class. Not everybody falls into this trap, but I would call this the data representation trap. I don't know. I got to think about types, and it just turns into this like huge mess, basically doing that. So one thing that you can ask is, well, how can you get out of that? One way that you might be able to get out of that is just to give up on the whole thing. Okay, forget about the typing. Okay, like just go back to the original thing where it's like price minus 5, times 150. Okay, we're going to go back to the problem statement. You're going to keep it kind of in the realm of the problem, and then on top of that, forget about the test. Okay, it's like test driven. Okay, so the softer people are going to get really mad at me now. It's like, wait, you just deleted the tests? I'm like, yeah, I just deleted the test. Maybe what I'll do to just kind of verify this thing is I'll just eyeball it in the interpreter. I'll say, let's do it at 510, and let's do it at 490, and just see what we get. 100. Okay, pretty much works. It's good enough. Okay, we'll roll with it. Okay, so there's that problem. Now, in stepping back from this a little bit, okay, let's kind of step back to the problem for a moment. Starting with that question of computing the attendees, that was not a totally crazy first step in solving this problem. I mean, one of the things about the problem is that there's a lot of kind of intertwined parts, right? I mean, like here, it's talking about like a function to compute like the cost. Like if you want to know how much cost I'm going to incur for some price, the way that you would have to do that is you would have to get the number of attendees, right? You'd first compute the number of attendees from the price, and then the cost would be this 180 plus 0.04 times the number of attendees. Kind of reading the problem statement here, but this is not something that I can really do anything with by itself, right? Because there's essentially a dependency in the code. Like this depends on the other function. So starting with the compute attendees, that's not it's not a bad choice. Okay, why not? Now it turns out if you start with the compute attendees, there's another kind of trap that you can fall into. So let me talk about that trap. So if you look at this function, compute attendees, it's got these hardwired values in there: 120, 5.0, 150, and so forth. And one of the things we learn as programmers is that you really probably shouldn't do that. Like write code that has the embedded constant in there, because then it makes the code really, really hard to change. I mean, in Python, you don't have to recompile it, but you have to go change the source code. And the movie theater owner is not going to be happy with that. He's going to say, Dave, I want to, actually the pandemic hit and the numbers are totally different. I mean, I got to change the numbers. And if the movie theater owner is going to be really mad if I say, well, just go modify the source. I mean, we'd all like to tell the customer that, like, oh yeah, just modify the source. Oh yeah, sure. Okay, modify the source. Okay, so this is not great. Now what you might think to do here is maybe introduce, I don't know, some constants or something. Now, I don't know whether this is much better than modifying the source, to be honest, but instead of having like those hardwired values, you might introduce some variables, base cost, base attendance, maybe attendance per dollar. This is going to challenge my spelling skills here. Okay, so maybe I'd introduce some constants in there, saying, okay, you should put some constants in the code. Now, doing something like this is going to get different sort of people angry, maybe. Okay, so software developers are going to look at that and they're going to say, oh, global variables, what are you doing here? And you could do this for like actually, this is base price. I'm already violating the first rule of programming, which is naming is the first hardest problem here. Okay, base price. Okay, so you have these named constants, and maybe I don't know, cost per attendee. Okay, so programmers going to look at this and they're going to okay, really global variables? This is what you're going to do here? They're going to remember something that they read on Hacker News or something about some car where the software, the car had 10,000 global variables in it, and it, like, I don't know, drove somebody off a cliff or something. And then they're going to think like, no, we're not doing global variables. Like, no. Okay. So this leads to like a whole different kind of line of thought in programming, which is, how do you make kind of encapsulated things, right? Like, how do you make pieces of code that are sort of like self-contained and so forth? And what somebody might do with this is they would say, look, I'm going to, instead of the global variables, maybe I'll just pass them in as argument. What they're thinking about is, having the code basically being like, like a self-contained box or something, like the inputs come in and then the outputs go out, and there's no dependency on global variables, basically. Okay, so just change it all to like variables like that. And then maybe you would do the same thing down here for the, the compute the cost, right? It's like we'd have a base cost and then like a cost per attendee. And we're gonna use that here. Okay, so we're not going to have global variables, but we're going to have function parameter like that. Now, doing that introduces this whole other headache. I mean, like on the surface, it seems like, okay, that's a reasonable idea, right? I'm going to make these like self-contained program modules, and I'm going to hook them together. But this dependency here suddenly causes a huge headache, because the compute attendees function requires all of these extra things now: base attendance, base price, attendance per dollar, right? So you would then need to like include those on like the the argument list, and then by including those, all of a sudden it's like, well, where are those coming from? Well, you would probably have to include them on the argument to the compute cost. So now, like, the compute cost function has got like 6 arguments on it, and everybody's head is exploding, and it's like, okay, what am I supposed to do with that? So it's suddenly taken this like this horrible turn, right? Of like dependencies, and I have this problem of like, well, how is data being passed around in the program? So, and then I've totally lost sight of what the problem, like what is the problem is that I'm trying to solve here, and oh yeah, find the best profit. Okay, so I kind of remind myself. So this problem of passing data around is, it's something real, and so one, so one angle on this is, instead of passing all of these things around like that, maybe they should be packaged up some way, maybe into a single object of some sort. One way that you might do that is you could introduce a class. Maybe you make a data class or something where it's like, okay, I'm going to have the theater model of some kind, and I'm going to put all of the parameters into the model. I'll just say, okay, there's a base attendance, and like that's an int, and then you have the base price, and then okay, now I'm back into the type problem again. Like, okay, I could put float there, but then should this be a decimal, or or is that cents? So okay, so I guess I'll leave it as floats for lack of a better thing right now, or it's just easier to type. Okay, so you're going to have like, you make some thing like this, data class, and you have the base cost not equal to float. Okay, be careful with that. Okay, so maybe you make like an object like that, and then what you're going to do is you're basically going to pass that around. So you just pass the model around to all of these functions, and you will just pull things off the model. The whole idea on this is that you don't have to worry about all those function arguments, right? It's like you can pass this one thing around, and then anytime you need something out of the model, you just refer to it. Okay, so everything becomes kind of simpler on that. I have to make sure that I'm like putting it together right here. Okay, so you're going to pass the model there, and then model base cost, cost per attendee, and so forth. Okay, so maybe you do this class, this class thing going on, and then you can certainly use that to start, doing other things, like maybe computing the the profit, for instance. Like let's say you want to compute the the profit here. We're gonna have profit where you give me the model, and then you give me the price, and essentially what the profit is going to be is you'll figure out like the number of attendees at that price. Okay, so you'll pass in the model, and then the price, and then the revenue from that is going to be the number of attendees times the ticket price, and then the cost, we'll do the compute the cost at that price, and then return revenue minus cost. Okay, so you'll do something like that. Now as you're doing this, you might notice that, wait, there's actually duplicated work, right? You have compute attendees taking place there, and then you also have you have it taking place up here. Right. So now you have this, like, okay, you're passing data around, but you're concerned about duplication of work, and like maybe those, okay, so those two things be separated in some way, right? Like maybe the compute cost thing, maybe it would be better for it to take like the number of attendees in as an input, and then I could get rid of the duplicated work, and then just kind of change the the parameters of the thing, right? Okay, so we're gonna change the way that data is being passed around. Again, you're running into like just sort of a huge amount of complexity with just like, how is information being passed around on this program, and what are the relationships between the parts, and so forth. I suppose I ought to check in on this thing to see if it actually works. I mean, given that I got rid of all my unit tests, I'm not exactly sure that any of this thing actually works. So I mean, we could try computing the profit at 5, and oh, I need the model. Okay, so now I've got to make the model. And I already forgot what all these parameters are. So like 120 and 5.0 and like 150 and 180 and 0.0. Okay. So like literally everything has become significantly more complicated with this whole thing. I don't know whether this is like, I don't know whether that's the right answer, but it looks plausible. It's not like 10 million or something. Okay, so you got that. You can kind of extend this line of thinking, by the way, with this model thing, and you could say, look, why do you have a class and separate functions here? I mean, this is kind of a muddled mess of objects and functional programming, or like what is this about? I mean, maybe the whole thing ought to just be a class definition. And then instead of calling it model, we'll just call it self. Okay, so maybe we should just make the whole thing just a proper Python class. Maybe I should just kind of, I have to fix a few of the methods here, but maybe we should do that. Just make it into a class. There's still this annoying bit with the initialization of this thing. So one has to, they would basically have to create one of these things. They would have to make an object, and they would have to specify the parameters, right? They would, the base attendance is 120 and the price is 5, and then the 150. But the problem is that this, nobody can read this. 120, what's that? It would be much better to do some kind of maybe keyword argument thing where where you can specify it in a more like a more verbose way, and you might even you might even look at that and start fooling around with things like, well, I don't know, maybe we should give them like default values. That way that, it's like, you can just change it in the one place, and then, it's not so bad. Oh, actually, I put that in the wrong spot there. Okay, so the problem is just, I don't know, it's like it's turned into like a plumbing problem at this point. I've sort of lost track of what we were even trying to do almost. It's like what were we trying to do? And then if you want to go further down this direction, and sometimes this happens in the class, people will look at this and they'll say, actually there's this idea in object-oriented programming. It has like this really fancy thing, separation of concerns. Like, like if you're going to work with objects, maybe what you really want to be doing is having like separate classes. Like you could have like a class that's like the revenue model, and then you could have a class that's like the cost model or something, and then you could have a separate class that's the I don't know, maybe the attendance model or something. So these should be like separate things that could be defined, kind of on their own, and then the theater problem should take all those and like compose it together. And then I'm not going to do that. My head is already so exploded from the other thing, that like separation of concerns. I got like a million concerns, and that isn't one of them right now. Okay, so but you could go down that route, and sometimes that happens in the course. People take the problem there, and they're like, okay, I'm going to separate it out into objects and classes, and it says like all this stuff going on, and like nobody can figure out what's happening. The code is just spiraling out of control with this like plumbing problem of code here. I'm gonna just make sure that I can actually do something here. Okay, so if I said theater compute profit, at 5.0. Okay, it still seems to do, still seems to do something. All right, so again, kind of lost sight of what was I trying to do in this problem exactly. I went down that hole, and okay, so it turns out that what I'm trying to do in the problem is find the best ticket price that maximizes profit. I haven't even gotten to that. I've just been dealing with like plumbing of data and parts and stuff like that. So, so another angle on this problem is actually to start with that. Maybe you could start with kind of the end of the thing and sort of say, okay, maximize profit. And I'm going to keep the earlier code around just because in the interest of time. But let's say you started with this other thing down here. Sometimes people look at this and they're like, feature. Okay, what are we doing here? Like maximize. And they're like, maximize. They're like, there should be a standard library function for that. That's probably a feature of Python, right? Like max. And you're right. There is actually, there's a built-in max function. And so maybe a way to think about this is that the best price is going to be max of something, right? I don't know, profits or something like that. Okay, I'm just kind of sketching out the concept here. Okay, sketch of a concept. You might also look at that feature idea and think, there's got to be something in NumPy for that. I mean, NumPy is kind of the standard, the standard thing for a lot of data science things. So somebody, would look at that and say, yeah, there's probably, I don't know, it's probably some kind of NumPy feature or something that can do like a max profit or something. But then the question is like, how are you going to do that? So you have to sort of think through the problem. It's like, well, okay, maybe what I would do is I would create like a range of prices, right? Like I would start at maybe $1 and I would go up to maybe $8 and go in 10-cent increments. Okay, so and I'm just guessing here. Okay, this is just some kind of guess on the range. That's not in the problem statement to go from that range. Okay, so not in the problem statement. So I'm just kind of making that up. And then maybe what I would do is I would compute the profits by doing some kind of, I don't know, maybe a list comprehension or something. Okay, we'll compute the profit on some price, for price and prices, and I don't know, do something like that, and then like feed it into the max function. I don't know whether I want to use the NumPy one or the built-in one. But that's kind of the concept of the thing. Is you would start with that. All of a sudden you're running in into other problems besides me not being able to type Python syntax. Okay, so you suddenly you run that, and then all of a sudden you realize that like the range function doesn't work with floats. You can't do this. You can't do range with floats. Okay, so somebody will look at the range thing and they'll say, okay, it doesn't work with floats, but I can make it work with integers if I just go back to cents, right? I can say, let's go from like 100 to 800 and just redo the thing as cents, and then I'll compute the profit where the price has been divided by 100 or something. Then I can like make the thing work. And I'm kind of cringing on the whole thing because it's like now I'm back to this problem of confusing units, right? Of like the problem is specified in dollars, and like why in the world am I suddenly switching over to cents just to do the range thing? And it's like that's kind of okay. That's just blowing my mind, that. And then but fortunately somebody like familiar with NumPy, for instance, they might look at this and say, look, NumPy actually has this function to do ranges. You can use like NumPy a range to go from 8 up to 1 to 8 in increments of 0.1. So you don't have to do the cent thing anymore. You can do the you could do that. You could just say, okay, let's go over the range, and then you get some answer out of it. Still with me on this? A lot of steps involved. Okay, so you might do that. At which point you realize that you've got the wrong answer. You're not actually reporting the best price. You're reporting the best profit. That's the best profit. That's not I hope that the price of a theater ticket is not $1,064. That would be crazy. So this thing is actually reporting the wrong answer. It's not asking the profit, it's asking the price. And so now we run into this problem of how do we associate the profit with the price. And there's all sorts of kind of weird things that one could do with that. You could maybe pair things up with Python tuples, for instance. Okay, so you could use a tuple in there and then run the max on it, and that will actually give you a pair of values saying that the best profit is 1,064 coupled with the price of 2.90. If you strictly want the best price, you could index it by 1 or something, and then get the best price out of that. You could also play games with kind of sort of NumPy stuff as well. I mean, one kind of interesting thing with NumPy that kind of makes this interesting is you could get rid of the list comprehension. It turns out that if you're in the world of NumPy, you could just say theater compute profit prices and do a calculation like that. The reason that works, you'll go back to like the profit there. Basically, prices is an array, and it turns out that if you are doing things with NumPy, you can often do calculations where you stay entirely in the world of arrays. You say compute profit prices, and all of a sudden it gives you an array of the prices. That leads to very interesting discussions, by the way, if you've decided that this thing actually had like a type hint on it of a float going to float, and all of a sudden you realize that method works perfectly fine with an array of floats, and then how do you express that? Let's try not to do that in the interest of time. Okay, so you can deal with arrays. You can also get into some things like little NumPy tricks. I mean, maybe what you would do to get the best price is you would just index the price by doing like profits like argmax or something. I'm using features of NumPy to do that, and I get the answer out of that. But the concern that I have with something like this, okay, we went down this kind of route of trying to map this to features. Is this code all that readable? I mean, like if I come back 6 months, 6 months from now, am I going to be able to understand all this hacks that I did? I mean, in some sense, what I've done is I've sort of taken some things that I know about, and then I'm like, I'm just going to hack the theater problem into these features. Keep in mind that the problem doesn't say anything about arrays. There's nothing in the problem that says anything about arrays or storing the arrays or anything like that. So this latter approach is kind of it's bringing in a whole bunch of other stuff into the problem. Even though I get the answer, it's bringing a whole bunch of other stuff. So one of the things that I kind of think about on this problem. So keep in mind, all of this stuff happens in this course. I give the problem to professional programmers, and they do all of these things, not usually all at once. They go in different directions with it, but all these things come up. But The thing that I think about, though, is something slightly different with this. So as a little bit of a tangent, over the course of the pandemic, my kids convinced us to buy a puppy, to get a puppy. They really wanted a dog, and they just broke us down. And like finally, they're like, okay, we gotta get a dog. Now, anytime anybody mentions like a dog, I gotta show a picture of the dog. Okay, so let me find my mouse pointer. Okay, so there's me with the puppy. That's Mabel. Okay, Mabel the puppy. And she's about 50 pounds now. Okay, so that's me with Mabel. So I'm a couple months ago, I'm out at the park with Mabel, kind of hanging out, talking to neighbors. One of the features of having a dog is you get to meet the neighbors. So I no longer have an excuse to never know anybody on the block. Okay, so I gotta go out with the dog, and I'm out there, and my neighbor across the alley comes over. He starts talking, and he's like, so he comes up to me. He's like, Dave, you wrote that Python book, didn't you? And of course, I'm always a little bit skeptical about it. It's like, yeah, okay, because I'm worried he's going to say, man, that book really sucks or something. No, but instead he came up and he's like, yeah, I've been thinking about learning some Python. My kid is in college, and she's doing some stuff at the university with Python. I thought it was kind of neat, and so I asked him, well, what are you working on? He's like, oh, I just want to do some stuff with stocks, my investments and stuff like that. So I'm talking to him about this, and then I start thinking about the problem a little bit. Okay, he doesn't own a movie theater, but he's got some practical thing that he's kind of working on, and then I start to think about all this stuff that I'm doing in here. And I think it's like, is my neighbor gonna get this? I mean, I sort of feel that like Python would be great for this guy. He's like, yeah, you could do all this stuff in Python, but like, what am I doing in here with this problem with the data classes and the ints and the objects and the like, what is going on? And so I sort of, I didn't say this, but I sort of imagined myself sort of turning to him. I say, I don't know, man, have you considered using Excel? And it's like, that's the problem with the problem in a nutshell. It's like, I sort of feel like this has gotten way too complicated to explain to my neighbor. Now I can't just leave you with this talk saying, hey, you should just use Excel. I mean, you're gonna say, Dave, what the hell kind of what talk was that? Like, that's like a terrible talk to have at a PyCon conference. Okay, so I guess one thing I would sort of maybe leave you with on this problem is that maybe it's okay to not make things so complicated. And I'll give you kind of an example of what I'm thinking about with that. So let me copy the code here. Okay, so instead of doing all of this stuff, okay, forget about the class. Okay, in fact, let's just delete the whole thing, because it's like, frankly, that was just getting out of control. The whole thing like that. Okay, so instead of doing that, maybe it's okay to kind of think about the problem in sort of simpler terms. Like I can look at the problem statement and I can ask, like, well, what is this thing trying to do? And what it's trying to do is find the best ticket price. Maybe just write a function for that, find the best ticket price, and not even think about arguments or anything. It's just like, okay, find the best ticket price. And then I can start thinking about how would this work? I mean, maybe there's a low price of $1 and a high price of maybe $8. And then there's like an increment or something of 10 cents. And maybe the code is just sort of like, something real basic. Like I just like start at the low price. I loop as long as it's less than the high price, and then I figure out like what the profit is. at that price. And then, I have to figure out like how to do the max and so forth. But maybe, maybe it's kind of fine to do that for a lot of problems. Like I kind of feel like if I were to write code kind of like that, I could probably describe it to my neighbor. And I think that's like a really important thing about Python. It's like it used to be, sort of a, time in Python's early development, it's like Python, it fits your head. And it was like, yeah, it was great. I mean, that's the whole reason we use Python. And so, so I'm kind of out of time, but in thinking about this problem solving stuff, I would just sort of put out there that it's still okay to try and write kind of real basic, simple code. I mean, you can always make it more complicated later, but that is the problem with the problem. And I will leave it with that and see if there are questions here. I'll see if I can make any sense out of the question part of this whole thing. So it's like a whole page of questions. Okay, I like, is one of the moderators gonna see if there's a question in here? So. Okay. I'm just kind of scanning through the questions, but I'm a little bit overwhelmed with the things there.
Yes, thank you, sir, for the insightful keynote. And I hope all our delegates had a better understanding as well. We can allocate around 5 minutes more to answer a few of the questions in the Q&A chat. Yes, can I direct you, like, I don't think we have much time. We'll be able to answer around one question. Can I direct one question?
Yeah, if there's go ahead. Yeah.
Yes, we have one question like, can't we switch to a sense base and avoid the decimal problem altogether?
Okay. Yeah, I kind of did that earlier. The problem is you run into these things where you can end up with like fractions. Even though you're doing sense, it can be really hard to like avoid fractions sometimes, and you can still get like floats kind of entering the picture in an unexpected way. So, I mean, it might be possible to just rethink the problem doing that, but that was the problem that I ran into. Is I had to do an integer division, and so then I had to make the decision of whether am I truncating it or do I turn it into a float or some other float thing like that. So
yes, we have another question. Are compute attendees and compute costs inbuilt functions, or are they functions developed for this specific problem?
No, they were written specifically for this problem. So they're like, if you saw me using that, those are, I have to write that. So.
Yes, we can move on to one other question, I guess. Since this is a head count, it's not continuous, can't we use integers when returning?
Okay. I don't know. That's actually something we debate in the programming class, actually, is that the notion of fractional attendees. Is that, do you like, are fractional attendees allowed? Where you would get like a fractional attendee in this problem, by the way, is if you did if you changed the pricing to do like 5 cents. Like if you said compute attendees to be, $5.05, then you get like half an attendee on it. And I don't know whether I have a good answer on that. That's one of these things that you can debate. Like, I don't know, do you have half people or not? It's not specified at all in the problem statement. So it's in this gray area.
Yes, thank you, sir. And I think we can have one more question. Is separator used when splitting only the string?
Okay, I don't know. Is there that's not something I did in the code, so I'm not really sure what to say on that. But. apologize.
Yes.
Yeah. One thing
that's-
that yeah, can I answer one question like that I thought is actually kind of the somebody asked about the
Yes, of
assert
course.
statement. One thing that you saw me do in earlier code is using asserts in a like in the file. Like I did this thing where I had like compute attendees and where you put in a price, and then I had like this assert statement that I put like right after the code. Where I would assert, like assert the compute attendees for $5.10 is equal to 105 or something. That is actually something that I picked up at a conference, believe it or not. I was watching somebody else's talk at a conference, and they were doing these asserts like after the function, just right there in the file. And I was like, what are you doing there? That's like, it's a, it's why are you doing that? And then the answer that he gave was really interesting. He's like, well, if I put the assert there, the code won't even import if there's a bug in the code. I was like, that's kind of neat. I like that. So asserts are actually a neat thing I like to do in code. So
yes, thank you, sir, for the insights. And yeah, I think with the time due, we can wrap up the session. So thank you so much for sharing your insights, and I hope the delegates got the maximum out of the session as well. And
okay.
Yeah, thank you, sir.
Okay, thank you for inviting me. Have a good rest of the conference. So
Yes.
all right, thank you.
Yes, so for the delegates, before winding up the keynote space, we have a few announcements. You're able to ask questions on the Q&A chat as you did here through a message in the Q&A chat, or else you can raise hand only in the lab sessions and unmute yourselves to do any clarifications with the upcoming sessions. And also you're able to collect your delegate pack with the t-shirt, pouch, and laptop stickers by filling out the form posted in the delegate groups. So make haste to order your pack before it's late. And also don't forget that those who reserve the delegate pack stands a chance to win a dinner voucher worth 10,000 by a lucky draw, and 9 other dinner vouchers will be gifted for the most engaging delegates selected through the AirMeet leaderboard platform. And also you have 2 booths where you can find more details on Matific and Isaac. You can join them and have discussions with the members in the booths, and also there will be interactive sessions and giveaways in the booths as well. So don't forget to join them in your breaks and own the giveaway gifts. And finally, kudos to the speakers for coming on board to share their knowledge. And also kudos to the organizing committee for organizing PyCon Sri Lanka to the Python community. I would like to give a big shout out to our diamond partner, Matific Sri Lanka, for making this event a reality together with ISEC, which is a global youth-led organization that strives to develop every young person in the world by developing their leadership through team experiences and global internships. And a huge thank goes to our good partner, Iveda, for joining hands with us. You can know more about Matific and Isaac in the booths as well. So, this is the end of the first session of PyCon Sri Lanka. And next up, you can join any session according to your preferred track. We will be back again at 10:15. Hope to see everyone again, and you can join the booths during the break as well. Don't miss out on those spaces to enjoy the interactive sessions and get the opportunity to stand a chance to win the giveaway prizes. So see you in the next session. Thank you.